Hey everybody, let's talk about covalent compounds a little bit more and why they form the structures that they form. So let's do a little, remember, dot diagram here. So let's talk about neon. If we look at neon, neon is right here in the periodic table. It's in group 18, so it has 8 valence electrons. And I'm going to indicate those valence electrons by little dots on the edges of my symbol for neon. So neon is happy. It is stable. It has achieved its goal in life, which is to fill its outer shell. So neon doesn't like to react with anybody because it's achieved its goal. Everyone wants to get 8 except for helium wants to get 2. And some of these guys can drop down and become like helium there. So we've already talked about ionic compounds. So let's do an example here of sodium fluoride. So the way, if you remember, an ionic compound worked was sodium had 1 valence electron, fluorine had 1, 2, 3, 4, 5, 6, 7 valence electrons. If you forget those, remember, you can just look at the table again. Sodium is here in column 1, so it has 1 valence electron. Fluorine is over here in column 7, so it has 7. And they basically strike a deal. Sodium will give up its electron and drop down to the next energy level, and it's happy. And fluorine will accept that electron, and it will gain an electron and be happy. And then this one is positive, and this one is negative, and they pull each other in. But what if we have, let's say, 2 fluorine atoms? So 1, 2, 3, 4, 5, 6, 7 on this one, and another fluorine over here. 1, 2, 3, 4, 5, 6, 7. Both of these guys want 1 electron. They're not going to give one up to the other one like we did with sodium and fluorine here. So it turns out that they strike a deal. They basically share these 2 electrons right here. So this fluorine gets to share that electron part of the time. So essentially it's got 1 filled there, and this fluorine gets to share that electron. And so they form a bond there. So noble gases like neon, remember, noble gases have full valence energy levels, which makes them stable. And everyone else is trying to become like the noble gases there. So what fluorine and fluorine are doing here is when 2 nonmetals, fluorine and fluorine are both nonmetals, so when 2 nonmetals come together, they can share electrons in order to get a stable formation. And we call this type of chemical bond, this is a covalent bond. So covalent bonds form between 2 nonmetals. Neither one wants to give up an electron, so they share the electron. The electron is actually flowing between the 2. And sometimes we indicate this sharing with a dash. So an F and an F, those are our 2 fluorine atoms, and a dash indicates that they want to share those electrons. There are a lot of guys who will do that basically. Everyone here in column 7, fluorine, chlorine, bromine, and iodine, they all will do that exact same thing. They all have 7, and so they will all share with each other. So what this basically forms is if you put a bunch of fluorine gas into a container, the fluorine will all bond up into a fluorine molecule. Oops, forgot my U. So 2 fluorines floating around together because that makes them stable. That makes them happy. Let's do another example here. Let's say we've got oxygen and oxygen. Oxygen has, if you look on the table, it's got 6 valence electrons. So 1, 2, 3, 4, 5, 6. And this one, 1, 2, 3, 4, 5, 6. So basically this oxygen says like, hey, can I borrow that? And this one's like, sure, as long as I can borrow this one right here. But they're still not happy because they have 6, they need 8 to be happy. So this one grabs another one here and shares it, and this one grabs another one. I know that got complicated, but basically they're sharing 2 electrons each. This one is letting this oxygen share 2 of its electrons, and this one is letting this oxygen share 2 of its electrons. This is known as a double bond. And so you would draw it like that. Each oxygen is sharing 2 of its electrons with the other oxygen. So oxygen also, if you dumped a bunch of oxygen into a container, the little oxygen atoms won't float around by themselves. They'll join up into an oxygen molecule, O2. So like that. And now they are stable. They have their outer shells full there. Let's do another example here. And let's do nitrogen. Nitrogen, if you look on your table, has 5. 1, 2, 3, 4, 5. It needs to get 3 more to be happy. 1, 2, 3, 4, 5. And so what this nitrogen will do is it will strike a deal with this nitrogen. It needs 3 more to be happy. So it will share 3 from here, and this one will share 3 from there. So 3 electrons from this one are also spending time around this nitrogen atom, and 3 electrons from this nitrogen atom are also spending time around this nitrogen atom. So this is known as a triple bond. And so nitrogen will form a triple bond with other nitrogen. So again, if you dump a bunch of nitrogen into a tank, it will start to form up with another nitrogen atom. And this is N2. You maybe have heard of this like putting it into your tire. So nitrogen gas is gives some stability to when you inflate your tires there. But that's why it's called N2, because it is a nitrogen atom joined up with another nitrogen atom to create a nitrogen molecule. So a lot of elements will do that. 7 of them, they'll form up with themselves. And they sort of form a 7 here. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And then there's one more. Hydrogen will do that with itself as well. Hydrogen likes to have it has one valence electron. It, remember, is an exception. It wants to become like helium. And so, which has 2 valence electrons. So this one will share there. This one will share there. And they will form a single bond together, and now hydrogen is happy. So hydrogen forms an H2 molecule. It's not an atom, because it's not just one hydrogen atom. It's a molecule, because 2 of the atoms are joined together. Let's do a few examples where it's not always the same element. And let's start with probably the most famous example of all of covalent bonds. So let's say we've got an oxygen here. And again, remember, it's got 1, 2, 3, 4, 5, 6 valence electrons. It would like to get to 8. Along comes a hydrogen. It's got 1 valence electron. It would like to get 2. So they strike a deal, and they share these 2 right here. And then, but oxygen's not happy. This hydrogen's happy. It's got its 2 valence electrons, but oxygen's not happy. So another hydrogen comes along. It strikes a deal with this oxygen. They decide to share these electrons. Now this hydrogen is happy, and this oxygen is happy. It's got its 2 additional electrons. So when we form this, we say we've got H2O, right? Water. 2 hydrogens, 1 oxygen, and they are stable there. Let's look at one more example here. Let's do another famous molecule. Let's do carbon and oxygen. Carbon has 4 valence electrons. That means it needs 4 more to be happy. It needs a lot. Oxygen, like we said, has 6. So this oxygen wants 2 more. It will strike a deal with carbon. It's like, hey, I'll loan you part of the time 2 of my electrons, I mean to say, if you loan me 2 of yours. So now oxygen's got its 2 additional electrons, and it's happy. But carbon's not happy. It's got now 1, 2, 3, 4, 5, 6. It needs 2 more. So another oxygen comes along. It also has 6 valence electrons. It wants 2 more, so it strikes a deal with carbon, and it shares 2 of carbon's electrons, and carbon gets 2 of its electrons. Now carbon has 1, 2, 3, 4, 5, 6, 7, 8. And this oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And so does this oxygen. And so now we have carbon dioxide, CO2. Remember, the technical scientific name for water is dihydrogen monoxide, and this would be carbon dioxide. So that is how these molecules form.